In this lesson, we're going to talk about trigonometry, and some important vocab we need to go over first is the definition of trigonometry. And if you break it down, trig equals triangle, and metry equals measure. So essentially, trigonometry is just a measure of a triangle. A trigonomic ratio is a ratio of the lengths of a side of a right triangle. So the methods that we're going to use today, we can only use on right triangles. And there's three kind of trig ratios that we're going to talk about. The first trig ratio is sine. And all sine is the opposite side over the hypotenuse. And to figure out what your opposite side is, for some examples, let's say we're trying to find the sine of A. So I like to circle my angle and then just label the sides. So if I start at my angle A and go drag my pencil directly across, that's my opposite side. Then what I like to do, I go to my 90-degree angle, my right angle, go directly across. That's always going to be my hypotenuse. And then the side that's left over, that's what we call the adjacent side. And we'll get to that here in a second. But when you're writing these trig ratios, you always want to label your triangles as so. So then the opposite side, when you write this ratio for the sine of A, is just little a over the hypotenuse, which is we labeled as little c. For the sine of B, the process is still the same. We're just starting at a different angle. So if you recircle, we start with B. We know our hypotenuse is always going to stay our hypotenuse. But this time, if we go across from B, this is now our new opposite. That's always going to be the hypotenuse. And that side is our new adjacent. So when we relabel, opposite is now little b, and the hypotenuse is still c. So that would be the ratio for the sine of an angle. And then the examples we're going to do at the bottom are dealing with numbers. This is just a general ratio dealing with these variables or these letters. Cosine is another trig ratio we will talk about, and the ratio for that is the adjacent side over the hypotenuse. So just like what we did in that previous example, if we want to find the cosine of angle A, we circle our angle, drive your pencil directly across, that's your opposite, go to your 90, drag your pencil directly across, that is your hypotenuse, and then the side left over is always your adjacent. So for the ratio for cosine of angle A, you just look, your adjacent side you label as little b, and the hypotenuse is still c. When you find the cosine of angle B, you have to relabel your sides. So if I circle angle B, circle B. Won't let me move my circle. And we relabel the sides. Always start with your angle and go directly across. That's your opposite. Our triangle didn't change, so that hypotenuse is staying the same. And the other side is your adjacent. So you might notice if you start with angle A and you label your sides, and then you find the ratio for another angle, the opposite and the adjacent just flip-flop. You might be catching on to that pattern. So when we write that ratio for the cosine of B, again, it's adjacent over the hypotenuse. We label little a as our adjacent and C is our hypotenuse. And the third trig ratio we're going to talk about is tangent. Tangent is just the opposite side over the adjacent side. So exactly like what we did in the previous two examples, start with your angle. So in this first one, we're finding the tangent of A. So we circle A. We go directly across. That's our opposite. Go to your 90, go directly across. That's always your hypotenuse. And the side that is left over is always your adjacent. So when we set up that ratio, opposite, which we labeled as little a, over the adjacent, which we labeled as little b. We now want to find the tangent of B. Well, we just kind of talked about this. We're going to recircle our angle because we're starting from a new one. So now we're starting with B. And like we said, when you change your angle in the same triangle, the hypotenuse is always going to be the hypotenuse, but the adjacent and the opposite just flip-flop. You might notice that pattern. So this is now our new opposite, and this is now our new adjacent. So when we write the ratio for tangent of B, opposite is now little b, and the adjacent is now little a. You might notice the ratio is just flip-flop. When your angles flip-flop, ratio. So that's how you set up those ratios. And you might be thinking, well, how am I supposed to memorize all these ratios? Well, we have a little saying. It's called SOHCAHTOA. This is a helpful little tool to make sure you remember those trig ratios. So SOHCAHTOA, that's something you should always write at the top of your paper when you are completing these problems. The S in SOHCAHTOA stands for sine. And just like we set up here, the ratio for sine is opposite over the hypotenuse. So, opposite and hypotenuse. The C stands for cosine. The A, if you look at the ratio for cosine, is adjacent over the hypotenuse. And then if we look at tangent, the ratio for tangent is opposite over adjacent. So the T stands for tangent, the O stands for opposite, and the A stands for adjacent. So saying it's going to help you remember those ratios and how they're set up when solving right triangles. If you need to, go ahead and pause. I'm going to move on to the next example just to make sure you get everything down. So now we're going to practice this. Here's kind of the steps for when you're dealing with trig. Always, before actually you do any of this, write SOHCAHTOA down. It's already written on your paper. I'm going to rewrite it. And I like to write it like this because it's even more helpful for you to remember those ratios. So we write so, I'm going to write an S, and I'm going to write it as this because it tells you how the fraction is set up, opposite over the hypotenuse. And TOA, for C, is the adjacent over the hypotenuse. And then for tangent, it's just the opposite over the adjacent. So I actually like to write it like that because it's even set up better for you to remember and set up your ratios correctly. So we're going to follow these steps to help us with example 1. You first always start with your angle. So I like to circle. So whatever angle I'm taking the sine or cosine or tangent of, I circle. Then label your opposite, your adjacent, your hypotenuse signs. Use SOHCAHTOA to help you write your ratio. And if we're solving, like we're going to do in the next method, there's more steps to that. We'll talk about that in the next lesson. We're going to focus on numbers 1, 2, and 3. So here in example 1, we have r is equal to 16. So this side right here is 16. S is equal to 30. So this side right here is 30. And t is equal to 34. So that side right there is equal to 34. So make sure you label those sides as well. And just as those steps, always start with your angle. And we're going to find the sine, cosine, and tangent. Sine, cosine, tangent of r. And that's how we abbreviate these ratios. Sine, it's spelled like sin, but you pronounce it sine. Cosine is just C-O-S, and tangent is just T-A-N. So, and we're going to start with angle R. The angle we're dealing with. That first step down. Then label your opposite, adjacent, and hypotenuse. So start at R. Go directly across. That's your opposite. Go to your 90. Go directly across. That's your hypotenuse. And the side is left over as your adjacent. Okay. Well, we just want to write the ratio for sine of that angle R. Well, go look at SOHCAHTOA. Sine is opposite over hypotenuse. So we labeled our opposite side as 16. So that's going to go on the top. We labeled our hypotenuse as 34. That's going to go on the bottom. It's really important. You must simplify your fractions. So 16 over 34 reduces down to 8 over 17. So there's the ratio for the sine of r. For cosine of r, we look at SOHCAHTOA. Cosine is adjacent over the hypotenuse. So go to your triangle. We labeled the adjacent as 30. That's going to go on the top. And the hypotenuse as 34. That's going to go on the bottom. And always simplify. 30 over 34 reduces down to 15 over 17. And lastly, tangent, if we look at SOHCAHTOA, it is opposite over adjacent. We set our opposite, we labeled as 16. And then your adjacent, we labeled as 30. Again, always reduce 16 over 30, reduces down to 8 over 15. So those are all your trig ratios for the angle R in that triangle. And B, we want to find all these ratios for S. You're going to find the sine of S, the cosine of S, and the tangent of S. Because we're dealing with the same triangle, the hypotenuse stays the hypotenuse. When we relabel, again, we're going to start with our angle S. We're going to go directly across. So S is now, here's our opposite. Again, our hypotenuse is staying our hypotenuse because it's the same triangle. So our new adjacent was our old opposite. So essentially your adjacent and your opposite just trade places. Okay? But again, start with your angle. Go directly across, that's your opposite. Go to your 90, go directly across, that's your hypotenuse. And then the side left over is just going to be your adjacent. So when we rewrite our ratios for the sign of S, you just label our opposite, which is now 30, over our hypotenuse, which is 34. And you can reduce 30 over 34, simplifies down to 15 over 17. For the cosine of S, it's adjacent over the hypotenuse. Our adjacent we labeled as 16. Our hypotenuse we labeled as 34. 16 over 34 reduces down to 8 over 17. And lastly, tangent, again, is opposite over the adjacent. We label our opposite as 30, our adjacent as 16. 30 over 16 reduces down to 15 over 8. And again, start with your angle, label your opposite, adjacent, hypotenuse, use SOHCAHTOA to set up your ratios, always simplify your fractions if you can. In the next lesson, we'll apply these same concepts but into solving and finding missing sides and angles of right triangles.